All right, I'm just going to start. Okay, welcome to my talk. This talk is going to be like Ryan's take on alignment. This is by no means like everybody's take or even the majority take, and I expect you to like leave this knowing more about Ryan's take principally, and maybe like don't assume that this is like what most people think. Okay? Yeah, feel free to like pester me with questions after this. It'll be fantastic. All right, next slide. So yeah, this is who I am. This is like what I did. I did a physics PhD. Now I'm trying to do like alignment stuff. The journey was like not that convoluted. Like most people doing alignment stuff seem to like come from like some weird background. So like there's a lot of physicists there. There's some like people from evolutionary biology, etc. A lot of ML people, obviously. Yeah, basically I just did. Oh, thank you. I just did this like EAGxAustralia fundamentals course. Everybody should do this. It's fantastic. And the Sari Matt's program in the first iteration, me and Peter Barnett and a bunch of other people just like worked under the tutelage of Evan Hubinger, who's a particular alignment theorist, and like, I don't know, got to understand his worldview. And from then I just like, there's like this massive deficit of people who know how to like hire/act on like alignment research agendas. And so this like pushed me like immediately into the technical director position of the Sari Matt's program. So if you want to like get involved, there are like many spots. Okay, let's actually get into the meat of this. Right, what is AI alignment? Well, AI is just like a vehicle for producing good impact. So if we have like some definition of good impact, aka human values, which can be like really nebulous and diverse, but like AI is just like the thing that enables this to happen. So if a state of the world is like worse than another state, and an AI can get you to the better state, your AI is aligned if it helps you get there. Okay? So what does it mean if the impact of AI is good? Well, either humans retain control of the future, and this is a good thing maybe, or human values are actualized by AI. We kind of like hand off control of the future. This is like kind of sci-fi and weird, but like a lot of people might think like humans don't do a great job of like handling things as it is. Maybe we need to like work out what we really want and then like build systems that can like enact and enforce this. Of course, there's like a fair bit of nuance, like which humans, which values are actually going to control the future. Why is alignment important? Well, powerful AGI seems possible. Every time someone says it isn't, they like set up a benchmark, it gets overthrown. You know, like just people's like meticulous predictions are just dropping and dropping for the time of like every like conceivable AI task that can be completed. It might arrive soon. We have like some interesting reason to think that AGI is like 20, 30, 40 years around the corner with some like reasonable probability. It might be bad by default for humanity and hard to make good. It might determine most of future value. It might lock off like vast parts of the future. It might like shut down the capacity of the human species to grow and evolve and like do effective things. It might actually enable amazing technologies and changes to happen as well. And we can probably do something about 3, hopefully. How soon might we realize AGI? Well, if you buy the scaling hypothesis David was talking about, which is to say like as you increase like parameter size, like data, all these kind of things you just like throw money at as algorithmic efficiency improves, etc. We just get like better and better models with like no cutoff. Maybe you don't even need to like understand what intelligence is to like just get like very powerful intelligent systems. You just have to throw a lot of resources and time and pressure at it like evolution, and eventually it just pops out. So if you take this and you combine it with like some predictions over various like biological anchors, right, which are like size of the human brain, the amount of computation performed by evolution to produce the human brain, et cetera, given some probabilities, we get a median estimate, according to this Open Philanthropy report, of 2050. That's quite soon. What does failure look like? What happens if we don't align systems? Well, AI can like maybe seek power. There's some like reason to believe that in a lot of different environments, under a lot of different like reward functions, AI might just like robustly seek power because most tasks can be accomplished better if you have more power. This is like the whole Nick Bostrom superintelligence thing. More recently, Cristiano's kind of framing of we get what we measure is like, imagine you have like an AI stock market. And like, you don't ever like put values into the stock market. You just say like, stock market, go and like do all the things that I want like to, that like seem like they are useful for us, like produce more resources for the economy, you know, like make people happy according to some measure. And then like later on you're like, oh wait, I've got to put in like crucial parameter that I didn't know existed. But the stock market is like so complex and I can't even like manipulate it now. And if I take one piece out, it just crumbles and society crumbles. We're kind of like locked in this weird dystopian future. Or coordination failure. Like a game theoretic kind of situation where a lot of powerful actors have a lot of powerful AI systems they deploy. Maybe there's some sort of like weird deterrence equilibrium you reach, like in some sort of nuclear deterrence sense, and you just like get locked into a weird coordination failure. You can't like get out of it, and maybe like some really bad things result because you can't like unilaterally shift to a new like good paradigm. Okay, so why might it be hard? Well, generally speaking, this is like the orthogonality thesis of Bostrom. Intelligence and goals may be like completely independent or like largely independent. In the space of possible minds, as you search over like more and more intelligent minds that you're trying to find in your system, most of those minds might actually like have values that are very different from human values. We don't have a lot of reason to think that these alien minds we're kind of birthing are going to have human values. And if like your system is robustly capable by that bottom axis, that means it's like quite intelligent. You can like put it in a bunch of different environments and it's like very good at solving problems. This by no means guarantees that it's robustly aligned to what you want. If you have a robustly capable system that is not aligned enough, you risk malign failure. It pursues objectives competently that are not what you want. Deception seems instrumentally motivated. So this little robot here, if you look at the dotted line, the robot initially starts off, it like acquires a goal towards B, okay? But the training process wants to update it towards A. So if it goes towards B, it gets changed. Its brain gets changed towards A. And then in deployment, we see it just always goes towards A because its brain has been changed. But if it pretends that it actually wants A, you see, the black line, solid line, then in deployment, it can like never be updated. It can just go off and pursue B robustly. So if like models acquire like long-term planning capabilities and kind of like understand they're in a training process, it just seems better to their current values to pretend that they have the values you want them to have, so they never get changed. Big neural nets are just like so inscrutable to analysis, it's crazy. Like you can imagine like trying to train an AI to like operate a smart vault, prevent a robber from stealing a diamond, but like you can do this yourself. So what you want to do, of course, is like make the AI like be able to prevent even more powerful robbers, like weirder situations, stuff humans can't do. And you can train an AI to be like more and more intelligent and solve ever more smart vault problems, but eventually you get to a point where you can't even supervise it. And this neural net might be doing something really weird, like it might have like put a screen in front of the diamond, said like, oh, it's still there, even though it's gone, because it's easier to convince humans the diamond is still there than it is to like actually protect it. And lastly, human values are pretty underspecified from like the actual kind of things humans do, and they're quite path dependent. Like where you were before determines what you want next. There's a lot of, I could go into more of this here, but it's just like, it's not that easy to write humans' values down on paper. It's particularly hard to put them in a neural net. Why not stop or slow AI progress? Well, there's pretty strong incentives for very powerful systems that like do pretty much anything you want. There's economic, there's military incentives. Right now, there's not like a huge military program that I'm aware of that is like trying to build like power-seeking AI that like does competent objectives in the world, but like, you know, people have talked about incorporating AI into missile defense systems. This seems kind of scary. And obviously, of course, like the big AI companies are all very competently pursuing economic incentives. Coordination is pretty hard. Like getting all governments to agree on like even very simple things, like even just like solving climate change, which to me feels like there's a lot of perverse incentives there, but I don't think they're anywhere near as powerful as the incentives for powerful AI. Like the economic power of powerful AI, man, like the oil and gas industry, probably nothing. So like coordination is quite hard when there's like these bad incentives. Maybe we don't even want to slow this down. Maybe there's like some like weird transhumanist future we want or something. Or like maybe we just want to like prevent the world being critically vulnerable to the next pandemic. Maybe like everyone's going to like get the capability to build bioweapons in their basement or something. And this is like a really scary future. We can only avert this kind of scary, vulnerable world if we have powerful capabilities to like, you know, make sure that people can't build weapons or something. So what can we do? Well, I see like two options. This is my framing. We can like do more coordination than we've ever done in history and like have just more robust open protocols for safety and prevent like all the bad actors ever from like being able to do all the bad things and like painstakingly solve this really weird complex alignment problem. Or we can like try and build the safest minimum viable product we can and like use this thing to do like safety research and prevent bad actors from acting. So the first one is like, okay, we have to slow AI progress down because like safety is just like not keeping pace. Someone might believe this. You would have to enforce safety culture, have like really good security protocols in all these like major labs, and just like have just excellent cooperation between researchers between different labs. Make sure people don't like accidentally like say, oh crap, this lab is getting faster to the economically lucrative thing. I'm going to like shelve the safety thing that I'm going to do and just like put my model out first, because that way I capture first mover advantage. This whole thing is like, you have to like avoid the worst commitment races ever with like huge economically lucrative opportunities. And then you like, at the same time, you're like, all your safety researchers, you're like funneling money and like time, and you're like, oh god, okay guys, let's work out what is intelligence. Like, how do you like build a system that like understands it's in the world and it's like decisions shape the world and stuff? And how can you like make sure that this thing robustly does what humans want it to do whenever, even like if it requires its own values in the process? How can you even like define what human values are and then like load them into the machine? Alternatively, you could build a safe minimal viable product, or at least like as safe as you possibly can. And there's like various alignment proposals. There's things like human in the loop alignment, which is like you have humans that can like call AI models, and at every stage of this process, you just like iteratively learn more things that like humans want you to do, and the human is always kind of like in control and can kind of see the product of the AI's outcome. So there's some proposals here like iterated distillation, amplification, and debate, etc. I can talk about more of these later. You can do like interpretability research. You can try and like pull apart the black box and see what's inside. Or you can train the model to give explanations for its actions. And of course, you have to avoid the obvious failure mode of like the model just is incentivized to tell you what you want to hear. And you can never inspect it at some point because it's like too big and complex. But there's maybe ways to fix this. You can ask AI to analyze AI. You can like iteratively build up more and more powerful models from models you understand. And at every step, you just like say, okay, well, given I understand this model initially, like I want to like employ it to like look at the next iteration of the model. Just make sure that this update is not introducing like bad incentives. And we can do like ambitious value learning proposals. Which is sort of like, maybe we don't know human values now. Maybe we can like train an AI to really, really understand them and then just like extract it from the model somehow. And eventually we can like, once we have a minimum safe, viable product, we can like employ this thing to do alignment research. At some point, AI is going to take over research, arguably. So why not like get it to help us align larger, more powerful systems? If we can't like slow down research enough to like be sure everything is right on our own without AI assistance, maybe we can build language models that are like powerful enough to do research. Also, maybe these models we build that are on the pathway to like building like the more and more powerful models can help us do actual like inhibition of bad actors. Surveillance, monitoring, like appropriate like referral to democratic institutions, etc. Anyway, so in summary, AGI might be here by 2050. It might be like very powerful, and there might be like strong incentives that like stop it being like not deployed. It might be very hard to make these systems align with human values and just like not fall into the common failure modes. And yeah, it might be like really important to do this because maybe most of future value is determined like by whether these models are locking us into bad futures or not, or like whether these models just kind of like become a second species that I don't know, just like doesn't allow humans to like regain control of our future because it's no longer in the best interest of the AI systems. But do not despair. There are proposals, and some of them like seem quite good. I can talk at length about those later. But yeah, like I think that like this is a field that is like recently just rapidly exploding in the amount of opportunities for people to get involved. Like there's so much money in this field compared to what was 5 years ago. There's so many like more little orgs popping up. Like in everybody's backyard, there's like another alignment like reading group or like another like organization popping up every other year. They can just like take on another few dozen people, and these feel like we're actually moving the needle potentially. So yeah, like get involved and like see what help you can provide. And yeah, here's some opportunities. So we have, of course, the EA Cambridge AGI Safety Fundamentals course. This is just like, starts off a bit of philosophy that I covered and like moves on through some of like the, oh yeah, here we go. I'll probably like make this available so you don't have to photograph it, but sure. Yeah, it's like a great introduction to some of these weird concepts here that I've like covered very briefly. This ML Safety Scholars Program, this is like skilling up in ML, so you can actually like assist people with their research agendas. There's the SERI MATS program, which I was involved with now, and I'm now running, and our main objective is to kind of like produce people who can like create new original research directions, or like enact existing promising research directions that are like critically bottlenecked by having people who understand and can enact them. There's the ML for Alignment Bootcamp, which is like run by Redwood Research. They're like working with Paul Cristiano, some other individuals to like enact some like minimal viable product alignment strategies. There's like various academic institutions, Future Humanity Institute, Center for Human Compatible AI at Berkeley. And there's lots of independent research funding out there, especially from the long-term future fund from EA funds. So definitely like apply to there if you even think like, hey, I want to like work for 12 months to like scale up in alignment research, you know? Hey, I can't like quit my job without like having some sort of financial support. I want to like, you know, really study this stuff in earnest, see if I can actually make a difference. They have like lots of opportunities for that. Of course, there's also things like ELK, the Inverse Scaling Prize just announced. These are like opportunities just like do a hackathon or something, get some people together and like try and solve a subset of one of these problems. And I just get some more further reading there. You can take another photo, I guess. Okay, are there any questions?
Hey, so I do academic research in a field completely unrelated to artificial intelligence, but I'm familiar with the general failure states, if you like, of academic research, like the intense pressure to publish and to keep churning out publications and grants. And it seems to me as though that typical structure for career advancement and for getting any kind of job security, in the case of AI alignment research, probably incentivizes the publication of information hazards and also rushing. And I'm just wondering if anyone is kind of thinking about ways to safeguard against that, because that is a perverse incentive that very much is kind of entrenched in research culture.
So I'm not going to say we're lucky for this, but I think like most of the like really wild AGI stuff seems to happen in like just a few labs, like industry labs. And of course, like these are, you know, people are very incentivized to publish research here. It's like economically lucrative. You know, there's like, yeah, it keeps the status of the lab going, et cetera. It draws more graduate students in. Yeah, this feels like, this is kind of maybe another perverse incentive. Yeah, I don't know any way to like actually fix this. I think some people have actually embraced this. Like Dan Hendrycks has a Pragmatic AI safety sequence. He's the author of the Unsolved Problems in ML Safety. So his approach is kind of interesting. It's like he thinks, okay, like all the incremental progress in AI seems to come from these kind of labs. I want to like create benchmarks and create like research opportunities and grants for people who like are already in these labs doing stuff to do like more safety relevant work. So he's trying to like kind of like divert some of that pressure that, like towards good ends. So that's kind of interesting as well. Other people are kind of like just really pessimistic about this. There's a lot of people who think like, oh no, there's just no way to stop this pressure from happening. This is like how the world ends. Or like, these are the people like driving the bad things. This is like the reason why we can't slow down, and therefore like we just have to like pour more and more effort into like making safety research happen faster. Yeah. Oh, okay. Was that, yeah, okay.
You mentioned that you had some like promising research directions. Could you talk a bit more about like what you think is the most promising things that people have come up with so far?
Yeah, I think like, so some of the earlier alignment proposals, mostly originated by Paul Cristiano and like collaborators, were like, let's do something like iterative, where we have a human who can, like here's an example, iterated distillation amplification, right? There's a human who can like ask a model, like we're trying to teach a model to answer questions. We're trying to scale up the model's ability eventually to answer questions humans cannot answer. How do we do this without like while making sure that the model is like not going to answer questions in a way that hurt people or something? What we do, like here's an idea. Human, like the AI can answer like a bunch of trivial questions that humans can answer. You give the human a question like, hey human, how do you like build a bridge? Human's like, oh, man, I don't know. But I can like decompose this into a bunch of sub-questions like how many like nails are needed or how many builder hours or something. And like the AI model can like answer every one of these. The human calls the AI model a bunch of times. It gets all these answers back. The human's like, oh, I can formulate an answer. And then it pipes that answer back into the model. And you just like iterate, and eventually like your model can answer questions that humans can't answer. But it's like, but like a human consulting a team of humans, consulting a team of humans, consulting a team of humans, like they could answer the problem. So your model like kind of asymptotes to like this massive tree of humans consulting humans. The thought is maybe this like at every stage of the process, because a human's involved in question decomposition, they can like make sure that the way the answers to pipes are solved is like robustly good for humans. So this like kind of there's some thought like that this doesn't like produce models that are like as powerful in the world. It's just like straight gradient descent on like a loss function. This is probably true. And so the idea is like, this is bad if like you deploy this model and like someone deploys a bad model and your model can't like outcompete it and like produce good results or something. This is a concern. So like, I think one of the most promising ways to address this is eliciting latent knowledge, which is from the Alignment Research Center. And it's like, let's design loss functions such that we can always extract the mechanism by which a model gives us, like whether a model's answer is true or not. And the way they do this is like okay, we have to like open up the model, we have to like penalize the model if it we create ways to penalize the model for merely just learning what humans want to hear, and then like saying that. And so they do this by like all sorts of mechanistic incentives, like penalizing the model for like referring to too many parts of its Bayes net or something. Yeah, I don't know. You should read their paper. It's pretty cool.
Okay, sounds good.
What specific technical skills would you say are in low supply and high demand right now in this space?
I guess like the ability to take weird heuristic arguments about things and make concrete research projects that you can like empirically act upon. There's like a big deficit here. Like, so there are some proposals to solve aspects of alignment, like relaxed adversarial training, that are just like, this is like cannot be implemented in like an actual algorithm yet, because like it's just like in theory it works, but it's like a pseudo algorithm or it's like pseudo code. Like writing a way for this actually to be implemented is like really hard to do. So it's like so I guess the two areas are like, number one, taking like weird theoretical alignment ideas and like making this actually concrete and realizable in ML systems. Two, like coming up with more weird alignment ideas. Yeah. I'm like also like, I mean like incredibly talented ML people are still in high demand, right? But I think like for the more theoretical weird category stuff, this is like people who have like really good math skills, people who have like skills like in evolutionary biology or something, like they understand like incentive structures and this kind of thing. People who like, yeah, like a diverse variety of mathematics skills, like everything from game theory through to like set theory, et cetera, like type theory, all this stuff seems to be like play a role in people's research agendas to some degree. John Wentworth has an interesting article called like his study guide, unless wrong, that talks about like a bunch of different mathematics kind of toolbox, like things you can add to your toolbox that might come in handy, and like you can like look at, oh, this person's agenda, this like draws from these 4 areas or something, Yeah, generally speaking, just like. You should probably like go and have a crack at some of Richard No's alignment research exercises. They're pretty interesting. They like will require you to like learn some math, some of them. So yeah, that's my advice.
What's the role that hardware constraints could possibly play on alignment research? I mean, are we going to end up in a situation where it's just becoming less and less accessible to the average researcher because you don't have access to a giant facility and several supercomputers and so on?
Okay, I'll answer that in a few ways. So first off, like sabotaging semiconductor supply chains is like a legitimate strategy to like, if you're really worried the world is like rushing towards disaster. But I'm not saying I advocate that at all. But it's like, maybe there are ways governments can actually like enforce things involving, yeah. For another, like you're saying, like it costs enormous amounts of money to run like these OpenAI DeepMind like training runs that are like at the forefront of alignment research, not alignment research, AI research really. And it's like maybe like we need to play around with like in the playground of these really large language models or something as well at the moment to like have a hope. Like if the large language models scale to AGI, maybe we need to like mess around with them a bit to like understand like where they fail, implement some protocols there, etc. Well, there are some like attempts, like a Luther AI released this GPT Neo something, I can't remember the acronym or whatever, but it's like an open source language model. So that's like, the whole idea there is like, we've made this big open source language model. It's not as big as GPT-3, but it's like getting close. And it's like, the idea is just like, this is open source for alignment research. And there's like they can just like, get on their Discord if you're like interested, and I'll like let you know how to do that later. But like, yeah, the whole idea is like, they have like a bunch of server time. They like want people to like muck around with this model and use it for like good ends. If they can like write a nice research proposal or something. This is like one way you solve the problem. But there's also like other ways. Like I don't know. There's like more money in AI safety than ever before. There's maybe not like enough money to just like do like a GPT-3 training run or something. But maybe there is. I don't know. If you like have a good proposal, if you can like really write up a really good proposal for why you would like spend this much money to like build a thing you can test, I don't know. You can play around with that. You can get some GPT-3 time or something on the like. You can like get some access to the GPT-3 API. You can like do something like this. I do think it is like a worry though that like academic institutions that might be trying to do safety research just can't compete in terms of like they just can't spend enough to like run a large language model training simulation like that's anywhere near the size of what people are doing in industry. This is like worrying. Yeah.
Yeah, going back to what you said about collaboration, like, do you think there's a way of avoiding like some sort of like arms race between superpowers? Because to me, it seems like the only way collaboration would happen is if superpowers would like share the source code with each other, which seems like really unlikely. Like, what are your thoughts on that?
Yeah, I think like you need to have. So why do like rational countries go to war? Why do rational actors go to war? Well, like presumably war makes everyone like a bit worse off. They'd be better off if they just like ran a simulation of who would win and then agreed to like divide resources that way or something. So why do they go to war? Well, maybe they don't like believe that each other's simulation is an accurate representation of the thing. Maybe they like can't see each other's source code enough to like check this thing, right? Or maybe like they can't like enforce commitments. You know, so like they make protocols, and these protocols like end up failing or something. Or maybe they have like irreconcilable differences. I think the latter is probably like not true generally. People can like agree on certain things. So when it comes to like avoiding commitment races, I think the most important thing to do is like have people like make it really clear what they want. Have like radical new norms and institutions set up. This like currently is just nothing like we have now, I think. I think like the way you avoid a commitment race fundamentally is you just like have just like such radical transparency that like everyone can see what you're working on, and
yeah, that's like, what I mean. Like basically sharing the source code, right? But
yeah, I think that's what you have to do.
Yeah.
Otherwise, I guess what you do is like you say like, oh well, we're in a commitment race. I just better hope someone's far enough ahead of the curve that like, you know, they can like afford to pay the alignment tax, and then everyone else like adopts that alignment tax as well, because it's like, oh well, we're not just gonna like, you know, there's no point us racing and deploying models like prematurely because that's just bad for everybody. Mm-hmm. Yeah, I guess the point is like you want to have people, if it's like very multipolar and like everyone's kind of like doing this commitment race stuff, it's like kind of scary because you can see how the first mover advantage might play a role in like causing people to like not align models properly if that's like quite training expensive. So you want to make it as training inexpensive as possible. That's one strategy, right? Reduce that alignment tax, reduce the amount of like server time they need to like align their model, or the amount of like time they need to like, you know, inspect it before throwing it away or something. This is very important. The second thing is like signing like ex-ante contracts, something as well. If there's a way to do this to avoid conflict and like prevent people from like being premature.
We have time for just one more question. So, and I guess.
Yeah. So if I'm not wrong, I think you just mentioned that one possible solution is making it easier to kind of like train these models rather than relying on massive data centers or something. Is that what you're saying? Or
I said make it easier to align the model. So like reduce the overhead required beyond that required to make them really capable at solving your economics problems. Also like reduce the overhead required to make sure that they like don't go rogue / pursue the wrong things or something.
Yeah, because I was going to say like, isn't it almost somewhat optimistic that it seems the direction most of these advancements in AI is taking is simply scaling increases, which although doesn't eliminate the concern of alignment, it at least means that most of these breakthroughs are probably going to be happening in major institutions, major companies, rather than some underground lab or a terrorist organization, or like it's more likely to be centralized, which is not guaranteed to be able to be controlled, but at least not so like you have absolutely no control over.
Yeah, I do think like the more multipolar the world, the scarier in some sense, but also like, so like slowing down AI progress kind of like you're just waiting around. Everything's getting cheaper and cheaper and cheaper. So like maybe this is like one of the reasons why it's just not a good idea to slow down AI progress necessarily. If like you can't enforce good safety culture, because like at some point everyone, like a lot more people are going to have the capacity to build your transformative AGI model or something. So maybe it's like we want to have a manageable number of people in that seat, and hopefully like also avoid commitment races at the same time. And like hope, like it's kind of a delicate balancing act. You want, like I'm not even sure governance proposals are like remotely going to be successful at slowing down AI progress. But I think like if it's absolutely necessary or something, like research for safety is just like so far behind, and this like becomes very, very important. You know?
Yeah. Could you also like possibly incentivize rather than like not slowing down research, but incentivizing directions that are more controllable, more visible, rather than like more decentralized?
What does that mean? Like, what are you imagining?
Like similar to what I was saying before, where you have, actually, I'm not sure how you would actually like kind of practically implement them. It's a bit of a ethereal idea, I guess.
I guess like one thing that's been talked about, so Chris Olah at Anthropic has this idea of microscope AI, which is like you're not trying to build an agent that acts in the world, you're trying to build something that like learns like just very good prediction mechanisms. We're going to like do really good science, but it's no agent inside it, and it's just like you like get the outputs of this thing, but you also can like use interpretability tools to like peer inside it and work out the kind of cool tricks and like scientific method type things it's done to get the result and apply these. So it's like, this is very good. Like if you like incentivize, if it turns out these things are like really economically profitable on their own, maybe there's some reason, and they're like way easier to build an agent AI, maybe there's some reason to build these things, you know? The thing is that I think that like most like lucrative things in the world for economic and military things are just be better, like they're just gonna favor agent architectures. Like agents are just gonna be probably so much better, I think. So this like is kind of hard. I don't know, talk to Chris or someone that from Anthropic.
I think that's all the time we have. Would you like to stay back for questions and stuff?
Yeah, I'll stay around.
Okay. You can ask your questions too. And the event is officially over. Yeah.